Thank you very much. Thank you for having me here, and thanks to Camon and the organization for inviting me to this event. I'm a newbie, I'm a greenie, but I do my best to talk a little bit about our stuff here. So we will talk about this today. This little guy, very, very important in the process. Doesn't look much, but it's the important part. So it's all about computer to screen in this part. So today you have wonderful printing machines. They do the best job. They are very, very accurate. But this little fellow has to be great quality, has to be up to the task. Otherwise, it doesn't make sense. This is really, really important. Okay, so I will tell you a few words about Lyscher in general. It was founded quite a few years back, 46, family company. It was back then also in computer to screen, but only for textile. This is before CTS, CTP, of course, everything. So everything manual, very simple machines. Since 2005, it belongs to a German holding called the Heliograph Holding. And in 20, we became a new building from the holding. This was newly built in Switzerland, where we have all production today, after sales service and everything. And again, specialized in computer to plate and computer to screen. So it's a lot of applications. This will be kind of a messy picture, but this is what we are doing. This is all the stuff. Is this the presenter? Yeah. Yeah, so this we will talk about today, called the Multi-DX. This is the system which we can specialize for all the smaller screens for the glass printing industry. This one we have about 60, 65 installations in the US, all over, but we also do the jet screen LT, big size on the left. This is big size screens for architectural glass up to, I can only talk meters or millimeters, sorry, so 8 meters, 320, I cannot convert that quickly. Today screen printing is changing, big size is going down. People want high-end system, very high resolution for electronics, so this comes in the CS compact system. This in the electronic goes up to 10,000 dpi today. So screen printers today, they are requesting 10,000 dpi. The round machine for rotary, very classic, goes to Bangladesh, to Pakistan, India, all these countries for home textile, bed sheets, and all this. And then we have the exposed line, which is then for flexo. This is for offset plates. Secure line is, just to mention very quickly, this we have a few in the States. This machine does this cash. So that's a very good machine. But please don't ask me for samples. I don't have any. So they are not there. So we have machines, this in the States, a few, Fort Knox, Fort Worth, etc. They have these machines since many, many years. A few other interesting places which I cannot tell you, fortunately. So that's the product range. But let's talk to computer to screen. So I'm talking about automation today. Why should you put the computer to screen in your facility? When I go to the printers, I see a lot. They have, again, great printing machines. They have a nice print shop. The floor, everything is up to date. And when you walk into the screen room, sometimes it's a different story. It works, it's nice, but yeah, there are improvements possible, definitely. So when you work with film, let's say what we call the traditional day, or the traditional way, you have, of course, all these steps. This is where you have the artwork you have to do from the customer, the RIP, to do the 4-color process, to process the 1-bit TIFF file. You have the film setter. Maybe you have 2 old film setters in the basement for spare parts. That's a high possibility, because they are dying. There are not so many allowed. And to get film is also quite difficult today. You need to develop the film, you have the inspection, the touch-up. You have to put the film on the screen, in the vacuum frame, put on the light, and all this. It's a lot of exposing, developing, of course, drying, inspection, retouching, a lot of steps to create this little simple guy. So a lot of steps, a lot of work involved. So computer to screen, in general, artwork design, that's the same, of course. Instead of sending the files to the film setter, you go directly to the computer to screen system. You develop, you dry, and you print. So of course, there's a lot of savings there. It's a lot of time savings, etc. So main benefits, there are many, but I put a few here. It's digital. So this is what some people struggle with in the beginning. Oh, there is no film. There is nothing to touch, nothing to see. You have to believe the image will be there. You just have to believe it. But some people, they've been doing this for 30 years with the film, and they struggle a little bit. But at the end, it works out. So that's a saving. Less human errors, of course. You get a higher quality today. The standard with our system is 2,540 dpi. That's the standard, but again, we go above 10,000, we go to 12,000. Today is everything possible. So you get high quality screens. Of course, the film cost is gone. If you buy film from a repro house, that process is also gone. You have everything in-house. You have control about your films, the production. No inspection and touch-up, no pinholes, faster. The film you have to store, that's also gone. It will be in the cloud or wherever. The positioning, we will come to that, because we put in the register from the, for example, common printing machine, we put in the CTS. We will have the same register system in our machine as in the printing machine. That's a very important point. Means all the colors will be in register. You have a very fast changeover in the printing press. Helps you save time, production cost. If the screen breaks, very, very quickly you can make a new one. The file is there, just make a repeat job, that's it. So this is the little guideline in two sizes. We call the multi-DX. It's really a multi-system for multiple application. It's an all-in-one, we call imaging systems, flatbed design. You can see a few pictures here. It's the different table. It's a vacuum table. You will see, so it's a hybrid technology. I will also talk about that with different laser types. So in one single system, you are not doing all of this, but in one single system, depending on the setup, depending on the configuration, you can do everything from pad printing. This is it's a metal cliché, but it could be also a polymer cliché. You have offset plates. Of course, the rotary screens, which are always made flatbed, from Gallus, Kocher & Beck, SPG, for example, and then they weld it and put the end rings on. Just letterpress, flat stencils, in this case. Magnesium copper is for embossing. I think we have 12 systems in the US for that. That's a niche market, but fully covered by Lüscher. Flexoplates, film. Then you might ask, why do film? Why buy an image CTS and do film? But some companies, white goods, for example, from washing machine, dishwasher, and all this, the front panels, it's many times it's screen and pad printing combined. So then you can do both in one single system. Two different versions. Smaller one, the 320, where you can fit. If we talk about common, for example, you can fit 2 screens, maybe 4, depends on the size a little bit. The bigger one, up to 6 screens. So you can cover then a 6-color job in one machine, in one go. This is the technology we are using. It's actually laser diodes from the telecommunication industry. So we have on the left is the UV range. We have 2 different wavelengths. In this case, it's always 4 or 5 nanometer to cover this. And on the right-hand side is the thermal laser for offset plates and flexo. And this is infrared. So here we are actually removing material to make these screens. And with laser diodes, the UV diodes, we are of course curing the emulsion with energy, not with UV. Kind of simple setup. You can see here the laser diodes, UV diodes, thermal, fiber optic. This is the laser driver unit, had 16 laser diodes inside, direct fiber, and this is the optical system, which moves then back and forth in the machine. The table moves in. So some benefits. I'm the sales guy. I have to tell you the benefits. That's my job. Why is this machine good? It's really maintenance free. This is not a laser, a CO2 laser or a fiber laser. It's really small laser diodes. They last almost forever. We have possibility to upgrade our systems all the time. One module has 16 laser diodes. We can have 8 modules in a machine, means 128 laser diodes. So 16 laser diodes has a certain speed. If you go 32, the speed is double. So that's just easy to calculate. But this is something that you can do after a year, 2 years, when production may improve, or you need more screens per day. You can always make an upgrade. Laser has really high output because everything is fiber coupled. There is no mirror system or anything, or UV lamps or whatever. It's really a direct connection, so you have almost no losses in the system. Calibration. Before every job start, the energy is calibrated. There is a sensor. You will also see this in the movie. A sensor checking, because every emulsion, every mesh type has a certain energy. So one may need 500 millijoule, another 400 millijoule. So this sensor will always make sure that the millijoule setting, the energy setting, is always correct. And that will be after 1 year, after 3 years, after 5 years, you will always have the same curing on the emulsion. No consumables, very important, because this laser, they last really forever. We talk about 20,000 hours. And what this system does is actually we are shooting pixels. So when there is a pixel, the laser will shoot or fire, whatever, and otherwise it just switched off. So that's not. Lowest energy, one laser diode has about 1 watt, so that's not much. And that's a big. A couple of years ago, no one asked me about energy cost or consumption, but today that's it's always a question. And again, resolutions up to 12,000 dpi. This is a few slides to show you at the end. This is the customized table. Everything is, it's basically a vacuum table. And what we do then is that we have to ask the customer, you know, especially you glass printers, you have so many different screen sizes. You have all kinds of register holes, maybe pin system, whatever. So we need, like, when there is a project, I ask the customer, can you give me drawings of every screen? Most of them say no, because they are so old, they have no drawings, they just have the screen, so they send everything to us. We digitize all the screen, and we create and think about a layout, how to position the screens the best way. We had a few installations in Germany last year for perfume bottles and all this, and they sent us like 45 different screens, all with register systems, and this has to fit into one table. And that makes it a little bit complicated, but it works. Yeah, the richer system, we will come for that, and the hybrid solutions, of course, that some, I think in your case, it's only screen, but there are also customers doing flexoplates and screens and whatever. Okay. So this is how a table could look like. This is the same customer, different sizes. So there are like slidable vacuum pads, you could say, that you can move around with. You don't see the register pin so well, but it's also included, of course, here. This is another, oh, sorry. This is the one, yeah. No, you have to go back. Yeah, this is a little bit larger screens. So the operator has then to have these positions, also have to remember, mostly it's the color system and also the setup in the spooler. The spooler is the output computer where we send the 1-bit TIFF files to the machine, it works with layouts or templates, we call it, so to make it easy for the operator. So you have to choose the right template, and in the template you have all the settings like millijoule for the emulsion, energy, starting point, position, register, everything is like hidden in that file to make life easy. This is also the little bit larger screen, so on the left you can do 2 in one go, but with a larger screen it only fits 1 here in this machine. It shows also another type. 3 screens, all with register. This is kind of interesting also. This shows then different setup, and this means that you can have, these screens are all the same size, but at the same, you can also have a different size. But that means that the template has to understand this has to be programmed in a machine. So you can, it doesn't need to be 6 screens in the same size. It can be 4 screens, the CMYK, or maybe 2 screens in a different size. It's just that we have to know it when we do the table layout. Complex like this. So each machine in this point of view is all custom made. All the tables are custom made. This is the larger version. This is the screen maker in Germany, in Hanover, who is doing a lot of screens. It's a screen maker, so he does everything from 8-meter screens, big size, down to the small ones. But he does a lot for a common customer. So this you can see 6 screens. So here we have CMYK, and then we have maybe a white and a spot color. So it's one job here, all loaded with a register pin here. The spooler software. So this is a lot of technical information, pictures, everything. I went to this customer when I was driving to my few people I know in the northern part of Germany. I went there in the summer and took a video. So I thought it's easier, maybe I show you a 5-minute video, how the setup works, how the machine works and everything, and that explains a little bit easier. So let's see if this goes, yeah. So again, he does a lot of different screens. So this is not a typical setup. So he can do also 1 screen. So but the thing is here that this customer he's delivering the screens for, he is doing a lot of 6-color jobs. So that's why he needs 6 screens at the same time. So you can actually load 6 screens and you can walk away. This is the layout, the template where you load the files. So now it's starting with the first, with the CMYK, with the 4 screens. So this is now the laser, the optic moving. So this we call the fast axis, and the table is then moving in the slow axis. And this is all in yellow light, that's why the color is a little bit difficult, but it's obviously in yellow light. And again, there is nothing, actually you see of course the light here, but you cannot see, there is nothing to touch, no film, nothing. So you just have to believe that this pixels are firing correct. Register is also easy to see. So now it will finish the four color screens. And now the next screen has a different setup, means it has to move to the laser sensor. It will check now the laser. This has 64 lasers, this machine. It will checking and readjust to the energy setting. This has a thicker emulsion, so this needs more energy. And then they will check the focus, the distance to the screen, so you're always, it's an autofocus system. And then you will start, so you see this moves now a little bit slower. But it's one job, so the operator load the screens, you press the button and you can walk away. And with the 64 laser system like this, it will take, I would guess, 15 minutes to image these 6 screens. Number 5 finished. And then we have the same story again. The screen number 6 has a different setting. We need to adjust, or check or readjust the laser. Check the focus. And this again has a faster emulsion, or let's say it's the mesh is a little bit finer, so it will be faster. You can see this is then not fast. So this machine can expose up to 4 meters per second. I don't know that. Maybe you can translate that to miles. I don't know, but it's really fast. Then everything comes out, and you can take them out. And then you take this out, you reload, and you start the next job. So that's it. And you can see, of course, the color change. You see the image a little bit here. They have, these guys have a little bit what I call a high-end development. You can develop by hand, of course. Just rinse the screens one by one, very simple. They have an automatic developing system with a magazine, because they have also bigger screens, and then you can put 10 screens in a magazine and just go through the developer. This is something they build themselves, very easy, holding device. I think it's aluminium for 6 screens, so these are the same screens again. Just put in, this goes through, gets developed, gets dried, comes out here nice and clean. And ready for print. I think this is, with this machine type, this is the most automated process you can get, this system. The largest system we have, which are then vertical system, they can also be inline, but this is more for larger screens. Then you have a magazine and they go through the computer to the screen, they get developed and dried. That's an easy. I have a few more slides, but any questions so far on this?
What is the quality difference between your process and the traditional process of making screens?
It's quite a difference, to be true, because when you have a film, you have the film, of course. You put the film here, you have the vacuum frame, the glass, so when you expose them with a UV light or with a metal halogen light, you always have light undercut. You have to go through the glass, you have a little bit spread, and the laser is direct. There is no glass in between, there is no film, it's just direct exposure. So it's...
Would you quantify in terms of dpi, like 60 dpi going up to 90 or 120, or like...
Yeah, if we talk about 2540, this is a standard screen, 2540 dpi. Okay. To get this with a film, you need a film with higher resolution to achieve the same, because it's more direct. You have no diversion with the glass and the film. So it's sharper at the end. It's a direct.
And just a comment, what our customers say about them is that when you put the screens into the machine is registered, and you can almost, you're good almost from container 1. And
yeah, that's the point. The changeover when you have a new job, because we use the same register in our system as in the printing machine. That's a huge benefit. When you mount the film here, you can of course have a scale or do something, but there will always be a little bit, it's not perfect. The film will be a little bit off in one direction, and then you need some time to get everything up to register, and then you start the final printing process. That's a big time saver.
Do you find it necessary to have the inline washer dryer?
No, not at all. As I said, this is really luxury. This guy has it because it's a screen maker. He does screens all day long. That's his job. But many customers, they just rinse it with water, with medium pressure, I would say, one by one.
So the pressure, different time, distance of the pressure washer really doesn't have much of an effect?
It has an effect, of course, but I mean, that's the same when you use film. It's exactly the same process. So that it remains if you have a computer to screen or film. The developing process is the same.
Is the screen light better, worse, similar to the other emulsions, the standard emulsions?
The screen lights, all right?
On the line, is the screen light better or similar to?
Depends a little bit on the application. We have so much energy with this, so we can really cure the emulsion really hard. There are, of course, other systems with less energy. Then what many customers have to do, then you have to change to a SPQ, to a special emulsion which is made for computer-to-screen systems, because they have low energy, and then you have ghost image, reclaim, etc., etc. So,
are you selling the emulsion?
No. I'm a machine guy. We sell only machines. But we can give you recommendations, that's for sure. So. But I always say we work with standard dual cure emulsions. We don't need any SPQ emulsions or any fast special computer-to-screen emulsion. A Lysher system does not require that. So. Okay. Another thing we have is the software department is quite big with Lysher. We do our own RIP system, we do our own tools for Flexo and etc. We have for offset printing special tools. And for the screen printing, we have developed something called Extend. And Extend is a very interesting tool because when you use film and also a little bit with CTS, when you exposure a 100 micron line, for example, the light will always, with film, it will go in more, so the line will be, let's say, 85 micron, or 80, or maybe 90. It will not be 100 micron. But with this system, you have then to, of course, without this software, you have to adjust the file in the prepress. The prepress guys working on the image, they need to take this into consideration. They have to adjust the file. And with this on the fly, you can have in the artwork, you have a 100 micron line, and we make sure that it comes out 100 micron on the screen. So the software knows this is a tool you activate. Of course, you have to do a few tests before, but we remove or add pixel in the image. So that's how we can make sure that the line is then exactly 100. It would have come out 90 or 85, but we adjust it so it will be really same as the artwork. Maybe more important in, let's say, high-end electronic and all this, but even for you, for barcodes, for QR codes and things like that, it's important. Also, the line sharpness and the line width it's important. So this is a very interesting tool. A good example, this is the TIFF. This is how it should like. Without any correction, normal exposure, it will go like this. You will lose a few fingers. Maybe not so bad at losing a leg, but the way it's not good. It's not good. And with a on-the-fly exposure, we really get what we want here. So you can see what you are doing. You are opening up the image, so the ink gets through when you print it. Yeah. And again, it's on the fly, so it happens directly when the file is sent to the output device. service and software, or service and maintenance, or service and maintenance, it's also important. I said, of course, the laser, they last forever, that's true, but it's still a machine. Things can happen, but we have created quite an interesting service. These machines are very, very simple to run, and they don't need much maintenance, but we have created something we call condition-based service and maintenance. So that means that on these small machines, all the maintenance can be done by the operator. It's very easy. There's cleaned optic, there is a filter maybe to change, and small things, clean the encoder. We don't need to come for that. That's not necessary. So what happens? You get the message down here, oh, it's time for maintenance. The operator can check this. What's going on here? You get the QR code. He can take his telephone, he scans the QR code, and immediately a mover will come up, and the mover will explain in which tool you need and how to open the covers and how to clean it and everything. So it's very good and very helpful. And this is very few. Cleaning the optic, it's maybe every 2 months, takes a few minutes. It's just small things, but have to be done. If questions comes up, we have, of course, online support. We can log in to the machine from Switzerland. We can check everything. We have 2 service companies here in the States helping us. One is a company who belongs also in the same group called K. Walter in Inman, South Carolina, right? Yeah. And the other one is Kivo in Houston. They also have service guys. Thank you very much. Maybe too quick, but hope you have a few questions.
Perfect.
Perfect, okay. Oh, not bad, yeah.
Any questions?
Yeah.
They air cooled or water cooled?
The machine?
Yeah.
No cooling. No, we don't need any chiller, nothing. So that's also a benefit, good selling point. That is, again, it's low energy laser diodes and it's fiber copper. We don't have any energy loss, so that helps us, you know. We don't need to cool anything.